Active Directory is a client-server network environment implemented by Microsoft Server operating systems like 2008 and 2003 Server. It offers many advantages and capabilities over both traditional peer-to-peer networks and non-Active Directory client-server architectures. Peer-to-peer versus client-server infrastructure. First, we'll take a look at peer-to-peer. This is characterized by small networks, generally less than 10 computers, non-centralized architecture. Passwords, user accounts, access control, authentication, and security are implemented separately on each computer. It utilizes NetBIOS-based workgroups instead of DNS-based Active Directory domains, and it's generally less expensive than client-server operating systems and hardware cost to set up, but more costly and time-consuming to operate on a daily basis, at least for large organizations. In contrast, we have client-server infrastructure. This is characterized by large networks, generally more than 50 computers, centralized architecture, where passwords, user accounts, access control, authentication, and security are implemented on central servers and propagated from those servers to every client on the network. It utilizes DNS-based Active Directory domains instead of NetBIOS-based workgroups, and it's generally more expensive than client-server operating systems and hardware cost to set up, but less costly and time-consuming to operate on a daily basis for large organizations. This is an example of a peer-to-peer network. Here, client authentication is decentralized, and both authentication and access control is implemented separately and independently on each client. In contrast, on the client-server network, all authentication is centralized, such that every client authenticates and has access control through servers. Let's take a look at adding users and configuring access control in a peer-to-peer network in Windows 7. In our first example, we're on a Windows 7 workstation. And in this example, it's a peer-to-peer network, so if I were to go and click on Properties and go into Advanced System Settings, you can see we're in a workgroup, Battlestars, and our computer name, our host name's Aphrodite. So if I go here, again, notice that the workgroup is Battlestars. So it's a NetBIOS-based peer-to-peer network. It's not domain-based. So therefore, authentication and access control are decentralized, and they must be implemented individually, independently, and separately on each individual host via the Security Account Manager or SAM Hive or database. So in other words, if I were going to make the users Clark and Anastasia, I'd have to right-click, go to Manage, and on every single computer in my organization, hypothetically say that we had 25 computers. If I were going to make login accounts for Clark and Anastasia on each of those computers, then I would have to go to each and every single computer and go into local users and groups, and I'd have to make new user, and there's Anastasia, and employee, and Clark. Okay. And creating these users, okay, yeah, I can log out and log in now on this one computer as Anastasia or as Clark, but if I had 25 computers in a peer-to-peer configuration, I'd have to sit down on every single computer and create these user accounts and the passwords and try to match them up to be the same, not make a mistake. And I'd also have to go and configure permissions such that, in other words, like local file permissions and even network share permissions on folders. If I open up the DACL and let's say I were to go to, pick this folder here, backup. All right, so if I were to go here to Properties, and if I were to look at the Security tab, and I were going to give any of those users permission, let's say I was going to give Anastasia permission on something on this particular computer, or a file server or whatever, I'd have to add Anastasia and Clark manually to each one. So there's Anastasia and Clark, and that's not so bad on one computer, but imagine having to do that 25 times in a row on 25 separate computers. And then also with all the amount of time it would take to edit the access control entries on the discretionary access control list. So, peer-to-peer networks are fine for small network situations where you maybe have 10 or fewer computers, in which case it doesn't really justify the expense of purchasing Microsoft's more expensive server products like 2008 server and getting higher end server hardware. But when you go over 10 computers, then actually it increases the maintenance cost. Yeah, you may have to pay more for a server operating system and higher end server hardware, but ultimately in the long run, you're going to save money if you move into a client server architecture, because you can centralize authentication and access control, and you won't have to do so much do so many things repetitively. Now we'll look at adding users and configuring access control in a peer-to-peer network in 2008 server. Here we're on an installation of 2008 server before we run DC promo. So we're still not client server yet, we're in a peer-to-peer architecture. And if I go over to my computer, from previous Active Directory setups, there's still like a DNS suffix, Optimus, battlestars.com, but really right now it's still just a peer-to-peer work group here. So there wouldn't be much advantage to having 2008 server in this environment until we ran DC promo. But just to show you, if I go to computer name, notice I'm in a work group Autobots, not in a domain type structure. Which means that instead of using Active Directory users and computers to set up users and groups and computer objects and things, here we would actually set them up locally. So just like in Windows 7, I'd right click, I'd say manage. And want to go to configuration and local users and groups. And just like in Windows 7, in this case we have a peer-to-peer situation, so I'd have to create Anastasia, and she's an employee. Now, remember that password complexity is turned on by default in 2008, unlike Windows 7. So unless you turn it off in the default domain controllers policy and default domain policy, you'll have to use a complex password. Remember, that's a combination of uppercase, lowercase, number, and a symbol. Well, 3 of the 4 of it. But the same situation exists. Even though I'm on a 2008 server product, if I haven't set up Active Directory, I still have a peer-to-peer situation. And I'm only creating these users locally in the local SAM Hive database or security account manager database. So I'd have to go on every single computer in the network, and I'd have to set up these user accounts, and I'd have to configure access control and permissions separately on every single computer. So it's not the most convenient way to do things. This time we'll be adding users and configuring access control in a client server network in 2008 server. In this example, we've run DC promo and left a peer-to-peer environment, and now we're in a client-server environment. So we've set up Active Directory, and now we have a domain. And I'm going to log in. Now notice that if we were to try to create local users and groups, we no longer have that option after running DC promo. That's really what we want. Notice that local users and groups has disappeared and is no longer available in computer management or server manager under configuration. That's because when you set up Active Directory and you leave a peer-to-peer and go to a client server architecture, the users and groups and computer objects that you set up are in Active Directory, not in the local SAM or security account manager Hive or database. So in this case, if we were going to add our users, I'd go to Active Directory users and computers, go to the users object, our node here, organizational unit, and I want to make a new user, and this time we'll do Anastasia. Okay, and again, password complexity is turned on unless you turn it off. It's turned on by default, but you can turn that off in the domain default domain controllers and default domain security policy if you want to edit that. Just look under password settings. Alright, so we've created Anastasia, and let's go ahead and make Clark. And Okay, and again, complex password, since we haven't yet turned password complexity off, which is a good thing. So now I've created Anastasia and Clark, but this time they're not peer-to-peer, they're client-server, and this time it's not locally in the SAM, but it's in the Active Directory database. This means that any computer in our domain, on our network, in our client-server architecture, if we had 1,000 computers, Anastasia and Clark could literally log into 1,000 computers. And whenever we make a change to their account, password changes or property changes on their user object, any of these tabs here, those changes would get replicated to other domain controllers. And again, we only have to do it one time. We wouldn't have to do it 1,000 separate times on 1,000 separate computers. So it's nice to have centralized authentication. In addition, when I set up permissions on the DACL, I can do permissions for the entire domain, all right, not just that particular local computer. So if I were to edit access control entries on the DACL, let's say that we'll make a folder here, and we'll call it data, okay, and I can go here, and I can go here, and on the security and the sharing tab, if I want to add or modify the user membership, I'll just bring up the listing here. We can add any users that we want from anywhere in the domain. I could add Anastasia, I could add Clark, and once I've done that, I'll just hold down Control and grab both of those there, and we'll add them to the DACL. Let's say I want to give them full permission for one reason or another. So if I did that, well, Anastasia's got read-only, Clark's got full. There you go. So anyway, if I did that, these user accounts would be able to, they would function, or Clark and Anastasia would be able to log in from any of 1,000 computers in our network, in our domain. And I only had to do that one time. So you can see how moving from peer-to-peer to client-server simplifies management, access control permissions, the creation and maintenance of user accounts. Take notice that we only have to create a user once in Active Directory's client-server environment, and that the user may then log into any computer in the domain with that single user account. Just to further the example along, I'm now on a Windows 7 workstation in the Autobots domain. In this case, I'm on the host Bumblebee. And if I bring up the login screen, notice that I can log into the domain Autobots, and I can also choose Bumblebee if I wanted to, the local machine. And I just type in, Bumblebee, the host name, and I could log into somebody locally in the SAM. But just to show you that, this user doesn't exist in the local security account manager here on this computer, but it does exist in Active Directory. So Bumblebee could be one of 1,000 computers, and having only added those accounts once to the domain, I can now do Now, even though there is no local security account manager or SAM Hive database entry for Anastasia or Clark, because this computer, the hostname Bumblebee, is a member of the Autobots domain, any user account I create in Active Directory is therefore accessible via any workstation or server that's a part of the domain. I can use those credentials, those accounts to log in, and I can access servers and file shares and things on the network, and I only had to create the user accounts one time. And again, just to show you, Bumblebee is a member of the domain. So it's a true client-server architecture. The domain is autobots.transformers. Transformers is the forest. Autobots is the parent domain structure. And there's the host name. Active Directory is organized into forests and trees. Trees are also referred to as domains, and these domain trees can have subdomains. A key concept of Active Directory architecture is inheritance, and it exists between all Active Directory objects within a forest. Through this inheritance, Active Directory objects maintain a parent-child relationship with other objects in the directory. A subdomain is a child of a domain tree. The domain tree is itself simultaneously a child object of its forest and a parent object to its subdomain. For example, here we're on our installation of 2008 server, and we're going to run DC promo and start the wizard to install or set up Active Directory, which means we'll be leaving a peer-to-peer environment and entering into a client-server environment. So from decentralized to centralized authentication, and from decentralized access control to centralized access control and permission management. I'm going to choose Use Advanced Mode Installation, click Next and Next, and we just want to look at some of the differences in Active Directory architecture in the domain tree and forest structure. So notice one of the options that I can choose is to create a new domain in a new forest if I'm setting up Active Directory for the first time, in which case all of the 5 operations master roles would be added to one domain controller. I could also choose to add a domain controller to an existing forest, and I have several options here. I could add a domain controller to an existing domain, such as a parent domain tree or a subdomain, and that would make that domain fault tolerant. I could add 3 or 4 or 5 domain controllers to that domain. If I did, it would be fault tolerant because if one domain controller or even 2 crashed, the other domain controllers would keep that domain going with the global catalog and the Active Directory database. Also, I could take the 5 operations master roles and load balance in this configuration because I could assign different operations master roles to different domain controllers and therefore optimize and improve performance. I have other options as well. In addition to adding a domain controller to an existing domain, I could choose to create a new domain in an existing forest. And this could be for creating a subdomain in a domain tree or parent that already exists within the forest. That's one option. I could also check this option here to create a new domain tree root instead of a new child domain. So in other words, if I were going to do this in the previous examples, the first thing I would do is create the forest. In this case, I would create the forest transformers. Then I would come over here, and then I might make it fault tolerant. I might add additional domain controllers to the forest to make transformers fault tolerant. And by default, each domain and subdomain within a forest forge an automatic two-way transitive trust relationship between other domains within the forest. This two-way transitive trust means that objects in one domain can be referenced and accessed by users and groups in other domains. In addition to these automatic two-way transitive trusts, one-way intransitive trusts that only flow in a single direction can be created manually. Effectively, whereas a transitive trust means that A trusts B and B trusts A, an intransitive trust means that A trusts B but B does not trust A, or vice versa. Here's an example of Active Directory inheritance and transitive trust relationships. In this example, you can see that the trust runs both ways, a transitive trust being a two-way trust, so that the domain trusts the forest and the forest the domain, the subdomain trusts its parent, and the parent trusts its child. Next, we have an example of Active Directory inheritance and intransitive trust relationships. In this example, there's a single one-way trust or intransitive trust between A and B. A will trust B, but that does not mean that B trusts A. For example, the tool used to manage Active Directory domains and trusts is Active Directory domains and trusts, and I just made a shortcut here, but it's in Administrative Tools, and open the tool, and in this case I don't have any subdomains created yet, but we'll use the previous example. So right now I just have the domain tree and the forest, but if I were to right click and select properties, I could go to the trust tab, and if I had time I would add the subdomains North America and South America, and when I did, when they were added as subdomains to the Autobots domain, there would be an automatically created built-in two-way transitive trust relationship between the subdomains or child domains North America and South America and the parent domain Autobots. So I could manage those trusts and inspect them and test them with this tool here. In addition, I can manually create a one-way intransitive or non-transitive trust utilizing this tool here, the new trust tool, and it'll run a wizard. So just be aware that that tool exists, and that is how you can access the trusts relationships. Once again, what does that mean? Well, that means if the child trusts the parent, in other words, if North America and South America are subdomains, and they trust the parent domain Autobots, then that gives me the capability to configure permissions on a DACL or access control entry so that even if I'm in a subdomain like North America or South America, I can add users from the parent domain Autobots and give them permission on a file or a folder or a printer or something just by editing the DACL. Active Directory utilizes a hierarchical DNS namespace whereby each object in the directory can be addressed by its fully qualified domain name or FQDN. This FQDN is a combination of the object's hostname, subdomain, domain tree, and forest, and is structured from left to right, starting with the most specific identity of an object, that is its hostname, and proceeding to the most general, that would be the forest. Let's take a look at one example of an Active Directory hierarchical DNS fully qualified domain name structure. Here we have a forest called transformers. We have a domain tree called Autobots, and then this domain tree has two subdomains, South America and North America. Finally, in North America, we have an example of two hosts. So the fully qualified domain name, or FQDN, for Optimus Prime would be, starting with the host name and moving from left to right, Optimus Prime, and then North America, and then Autobots and Transformers. Optimus Prime being the host name, North America being the subdomain, Autobots being the domain or the parent, and Transformers being the forest. Often, many organizations will utilize an Active Directory domain structure that integrates with their Internet DNS domain structure at the top level. Therefore, forest names would be the same as top-level IANA DNS names like .com, .org, .mil, .edu, and so forth. Here's an example of just such a fully qualified domain name structure. In this case, .com would be the forest, and this would integrate with top-level IANA DNS namespaces. Within the forest, we have subdomains, Fleet and Cylons, and then within Fleet there are subdomains, Cylon Allies and Battlestars, and finally in the subdomain Battlestars we have two hosts, Galactica and Pegasus. So another example of an FQDN or fully qualified domain name would be galactica.battlestars.fleet.com, where Galactica is the host name, moving from left to right, Battlestars is the subdomain, Fleet is the parent domain, and .com is the forest. Active Directory implements a fault-tolerant multi-master architecture within its infrastructure. This method departs from earlier implementations, such as Microsoft's old NT environment. In the old NT environment, there was only one PDC, or primary domain controller, and multiple BDCs, or backup domain controllers. In the old NT design, the PDC was the only domain controller that could create and delete user accounts and modify objects. The BDCs contain read-only copies of domain information. Therefore, if the PDC went offline, there were many things that could not be done in an old NT environment until the PDC was brought back online. This changed with the advent of Active Directory's multi-master architecture. Under this new model, there are no BDCs. All domain controllers in Active Directory have read-write copies of all domain objects. Any domain controller in a domain can create, delete, and modify objects. This minimizes the impact on the domain when any one domain controller goes down. Two key features of Active Directory's multi-master domain structure are fault tolerance and load balancing. Both of these goals are achieved through the employment of multiple domain controllers that contain read-write copies of domain information. Active Directory domains can be made fault-tolerant by adding additional domain controllers to a domain that can maintain the domain if other domain controllers go down. Active Directory load balances in a similar fashion. Other domain controllers are added and network services and responsibilities can be shared and balanced between multiple servers so that no one server is doing all the work, enabling optimal performance. Another key feature of Active Directory is that it creates a searchable database of all objects stored in it. Users, computers, printers, and other objects can be searched by site, location, or many other data attributes that are properties of each object that populates the Active Directory database. In addition to these capabilities, Active Directory implements a true client-server architecture that centralizes authentication and access control throughout the network. Users and groups can be added once to Active Directory via a domain controller. Once added, those users and groups can be accessed from any workstation or server throughout the domain. For example, in a peer-to-peer network, if we were going to create the users Clark and Anastasia and give them a login account on each computer in the organization, we would have to redundantly create the same user accounts on each computer in the peer-to-peer network. In contrast, in Active Directory's client-server environment, the users Clark and Anastasia need to be created only once on any domain controller in the domain. They may then use their accounts to log into any workstation or server within the domain. When an object is modified, created, or destroyed on one domain controller, those changes must be propagated to all other domain controllers and synchronized within the domain through a process known as replication. Replication occurs automatically at regular intervals and may also be implemented manually. All replication traffic is encrypted via a protocol known as Kerberos version 5, thus hardening this traffic against hacker activity. Although multi-master architecture and replication solves the problem of fault tolerance, it inadvertently creates another. Since any domain controller can make changes to the Active Directory database, the possibility of conflicts arise. What if an administrator on one domain controller adds Clark, while an administrator on another domain controller deletes him? Here, a conflict has been created within the domain and it must be resolved. When this situation occurs in Active Directory, it is referred to as a replication conflict. Active Directory uses two primary means to resolve replication conflicts, a timestamp and a serial number. When any changes are made on an object in the directory, that object's serial number is incremented, much like the odometer on a car is incremented after it drives another mile. When one domain controller receives replication traffic from another, the serial number is then compared against all objects in the directory database. Imagine, an administrator on domain controller A changes Clark's last name to Smith, and the serial number is incremented from 442 to 443. An administrator on domain controller B changes Clark's last name to Kent, and the serial number is incremented from 443 to 444. In the next replication cycle, A and B synchronize their information. This creates a replication conflict that must be resolved. A and B compare the serial numbers of the object Clark, and the change with the highest serial number value wins the conflict. If both serial numbers are the same, the timestamp is used. This timestamp is affixed to each object when a change is made, just like the serial number. If the serial numbers are the same, the object with the most current timestamp wins. Using a timestamp requires that all system clocks on each domain controller in Active Directory be synchronized. If domain controller clocks are not synchronized, replication will fail. To facilitate this process, one domain controller in the domain serves as the PDC emulator. This one domain controller presides over the replication synchronization process between domain controllers. Even though Active Directory implements a multi-master environment, there are certain rules that must be held by only one domain controller in the domain to resolve replication and infrastructure conflicts within that domain. These unique roles that are held by designated servers in the domain are known as operations master roles. If a domain controller holding an operations master role fails, that domain controller's master role can be assigned to another domain controller, allowing recovery of lost functionality. However, while a domain controller with an assigned master role is functioning, no other domain controller can hold that assigned role. Once again, this compromise is necessary to resolve conflicts in Active Directory's multi-master infrastructure. There are 5 operations master roles. 1 is PDC emulator, 2 schema master, 3 infrastructure master, 4 RID master, and 5 domain naming master. The first operations master role we'll talk about is that of PDC emulator. As mentioned previously, among other roles, the PDC emulator processes password changes and functions as Active Directory's official timekeeper when organizing replication. In addition, it serves to maintain backwards compatibility with older NT environments by functioning as a PDC would under old NT architecture. The next operations master role we'll take a look at is that of schema master. The schema master presides over Active Directory's schema and must be consulted anytime modifications to the schema are made. For example, when installing Exchange Mail Server, certain attributes and fields are added to the default user object in Active Directory, for mailboxes and things like that. The schema is the skeletal structure or framework of Active Directory. The skeletal structure can be modified, and a built-in object's properties, such as the user object or computer object, can be expanded or deleted, affecting the entire Active Directory forest. Next, we'll take a look at the infrastructure master. The infrastructure master maintains Active Directory's infrastructure and is the final authority when changes to the infrastructure are made. It constantly compares its data to the global catalog, a database of all objects in Active Directory. It also maintains group membership. When the infrastructure master determines that its data is out of date with global catalog data, it initiates replication with other domain controllers to bring about synchronization and convergence. Convergence is when all domain controllers have replicated and then contain the same Active Directory information. Next is the RID master. The RID master holds relative identifiers and administers banks of SIDs, or security identifiers or security IDs, to each domain controller, usually in quantities or banks of 100. These SIDs must be unique for each object in Active Directory, so the RID master ensures that. However, to avoid a performance bottleneck and create a multi-master environment, the RID master issues groups of SIDs to each domain controller. Only when a domain controller runs out of SIDs must it then contact the RID master to get more. This ensures that domain controllers never give any two objects the same SID, while still providing each domain controller with a measure of independence and therefore fault tolerance. Finally, there is the domain naming master. The domain naming master ensures the uniqueness of all domain names within the forest. As such, it must be consulted each time a domain or subdomain is added or removed to enforce the integrity of the forest and maintain the uniqueness of each domain name in the Active Directory hierarchy. For example, to change operations master roles, you can use Active Directory users and computers and Active Directory domains and trusts. So if I open up Active Directory users and computers, now in this example I don't have any other domain controllers to transfer them to. So I'll be able to show you the menu entry, but I can't actually do it until I set up some subdomains. But I would select my domain, right click, Notice on the menu there's Operations Masters, and then I can select any of these 3 tabs to transfer the RID, PDC, or infrastructure role. Now I would want to be on the domain controller that I'm going to be transferring to, as opposed to the one transferring. And on that domain controller I would go here and I could select this tab. Right now this is the only domain controller in the domain, so again it holds all 5 Operations Master roles. But later, to load balance and optimize the performance and efficiency of my network, I could transfer these roles to another domain controller. In addition, I could open up Active Directory Domains and Trusts, and if I did this, I could go here, right click on Active Directory Domains and Trusts, and select the menu option Operations Master. And here I could transfer the Operations Master role of Domain Naming Master. Again, I would want to be on the domain controller that I want to transfer it to, and then I would transfer it from this one. Another key component of Active Directory is known as group policy. It gives domain administrators the ability to configure and enforce security on every workstation and server that is a member of a particular domain. Through group policy, software applications can be installed and upgraded throughout the domain without the administrator ever leaving their desk. Desktops can be locked down and features enabled or disabled throughout the domain. The presence of unauthorized software and malware can be prevented. Internet and network security settings can be locked and enforced. Just about any customization imaginable that you could implement on a single machine can be applied to an entire domain through group policy. For example, as an example of group policy, if I go to Administrative Tools, I can open the Group Policy Management tool. And when I do this, notice that here's my forest and domain, and any domain tree roots I may have and subdomains. And I can go through and I can create what are called group policy objects, and I can create and link them to domains and different types of structures, organizational units. And I go into a lot more detail about this in other videos, but again, I'm trying to keep this brief and just make it sort of an introduction to Active Directory. So we'll explore this on a much deeper level in those other videos. But if I were going to edit or create a domain policy, I could right click, I could say edit. I could go in and notice that there are several different configurations here. So I have different policies under software settings. I can control software installation. Under Windows settings, I have scripts, log on and start up and shut down scripts, log on, log off scripts. There are security settings for password management, account settings. Go over here, password policies. There's just thousands upon thousands upon thousands of things that you can control via group policy. And the cool thing is, when you modify a policy and apply it, it affects every computer in your domain. So instead of having to do that 1,000 times on 1,000 different computers in a peer-to-peer network, with group policy I can do it only once on one domain controller, and it replicates to the other domain controllers, and that could affect 1,000 or 10,000 computers, however many were in my domain. So it's a very effective way of managing security and policy settings. In addition, you can do all kinds of things like lock down certain features on the desktop, prevent users from managing things or changing their network settings, control what websites they go to. Just about anything you could think of or customization that you could imagine by hacking or editing the registry, you can also do in group policy. But the difference is editing the registry database on the local machine only affects that one machine in a peer-to-peer environment, whereas group policy would affect every single computer in the entire domain. Active Directory provides many of the standard features of a modern network environment, such as DNS, DHCP, web service, FTP service, file service, and print service. As an example, take a basic service like DHCP. In addition to standard dynamic IP assignment, Active Directory enhances security through DHCP server authorization and secure dynamic update. Authorization prevents rogue DHCP servers from being accepted in a domain, and secure dynamic update secures DNS. For example, if I open up the DHCP server in Active Directory, every DHCP server has to be authorized. If it's not authorized, then clients won't accept it, and it won't really be received in the Active Directory environment. So in other words, in this case, this one's authorized, but if I unauthorized it, I would have to authorize it for it to function or it to work. And this requires typing in the domain or enterprise admin credentials, which means that you'd have to have an ID and a password. So it's one extra step. It's not bulletproof, but it makes it at least more difficult, or gives you a little bit of security against people bringing in a laptop and, say, running a bad DHCP server. And a hacker could do a lot of damage with something like that. In addition, the DHCP server integrates very well with Active Directory. So if I were to right-click on IP version 4 and go to Properties and the DNS tab, notice that yes, we have Dynamic Update, but we can also do something called Secure Dynamic Update if we hop on the DNS server and we turn that feature on. And this means that only clients that are members of Active Directory and have computer accounts on Active Directory users and computers would then be allowed to lease an IP address. And again, we explore this in a lot more detail in other videos, but I'm trying to keep this brief to show you some of these features. Another example is DNS. In addition to standard hostname resolution, which uses non-encrypted zone transfers, Active Directory provides enhanced security through Active Directory Integrated, or ADI DNS. ADI DNS encrypts DNS information via Kerberos version 5 and sends that information from one server to another by replication. For example, so if I open up the DNS server management tool, let's take a look at it. And I'm just going to go to a forward lookup zone. Here's Autobots, Transformers, and notice it holds the A records for IP version 4, and so it's quadruple A version 6 and single A version 4 for our host and whatnot and things. But if I were to, let's say, click on Autobots, Transformers, and let me go to Properties here. And notice that in this case, it's Active Directory Integrated. And so in this fashion, I'm doing DNS with, it's being encrypted with Kerberos version 5. And the information is transferred as part of replication traffic. Okay, now that could be changed. We could go to a standard DNS model to make it backwards compatible or compatible with Linux, bind DNS or something. But this is a significant improvement because instead of using, plain text or unencrypted zone transfers, Active Directory Integrated uses encrypted communication, and it transfers it after it's encrypted with Kerberos 5 via replication traffic. In addition, notice that we have an additional feature with DHCP and DNS, so they cooperate or they work hand in hand, and that's the secure only. Now you do have dynamic update, which is non-secure and secure with other operating systems and environments like Linux, but Microsoft exclusively has sort of a secure only capability setting in the DNS. And remember, that means that the workstations would then have to be a member of the domain, which means that somebody would have had administrative or domain credentials to join them to the domain before they're allowed to lease an IP address from the DHCP server. So some very interesting and nice security features available in Active Directory. Another example would be the Web and FTP server. Active Directory integrates Internet Information Services, or IIS, to serve out websites and intranets that implement FTP servers within an organization. It includes many features that integrate with certificate services, active server pages, and database technologies. In short, Active Directory is an outstanding, versatile, and secure technology for most modern networking client-server environments.